Partial derivatives. This is when things get a little bit messier when it comes to the math. We got our producer up and running, making sure everything is going all good. Please don't bite me. Yeah, Asher's deciding he wants to help today. So let's talk about partial derivatives. Uh, what are partial derivatives? These are for finding the slope of a function that has multiple variables in one of the find the slope of a function that has multiple variables in one of the multiple directions. When we have multiple inputs, we no longer have just a straight line as our graph or a curved line as our graph. We have things that might have multi-dimensions. So if we have two inputs, we get a third output. That's going to create a three-dimensional surface. So the directions of that surface go at different angles when you look at a single point. So let's talk about why we need to do this extra step. Well, I just mentioned that when we have two inputs, we get a three-dimensional graph. We have four variables, four inputs in the Pokemon damage formula. So we need to really be able to understand how we can take the one variable, step it up to two variables, and then we're going to be able to go even further and reach the four variables that we need to when we're looking at the Pokemon damage formula. So this video, we're just looking at two inputs to keep things simple for us to introduce this idea. So a multivariable function, when we have two variables, like I just mentioned, it creates a three-dimensional surface. Two inputs creates a 3D graph. So we could get something that looks like this when we have 2x squared y cubed. So the slopes now go in three directions instead of just rise over run. We have these three directions that everything's going. To find a partial derivative, we look at one variable at a time and imagine the other stays constant. So what that means is we chop our three-dimensional surface and we only look at one direction at a time. So as you can see here, I've chopped it, so we're only looking at something that looks a lot more like a parabola, something we're more used to. So we're going to find the partial derivative with respect to x, which is the slope of this parabola shape. So we're going to imagine that the y's weren't changing. We just took a slice, we took a cross section, and we're looking for the slopes of that cross section. So y is a constant. It's not changing. So we can treat it like a coefficient. So we're going to reorder and regroup using the associative and commutative properties and get 2y cubed times x squared. We rearranged our formula. Now we can take the derivative with respect to x. So just taking the derivative, treating x as our only variable, using the power rule, where we bring our coefficient down in front, subtract the power by 1, so we get 2 times 2y cubed times x, which we can then regroup and multiply our coefficients to get 4x y cubed. So that is the partial derivative with respect to x. That formula tells us the slope at the points when we're just looking in the x direction. Well, if we look at the y, we chopped as our cross section of x, we get something that looks like a cubic function that has that slope down and around. So let's treat x like our constant. We regroup it, so we get 2x squared, and then our only variable we're thinking about or considering this time is the y. So we use our power rule. We bring the 3 down, subtract the power by 1 to get y squared and a 3 out in front. Regroup, reorder, and we get 6x squared y squared is the derivative with respect to y. So what comes next? We've now discussed that maxes and mins occur when we have derivatives that are equal to 0. Now we're working with multivariable, so we're working with equations that have multiple derivatives. So we need to take the first part. Take the fact that slopes equal 0 gave us our critical points. Now we have multiple equations. We have to set each of those equations equal to 0 to figure out what those optimal critical points are. So in the next video, we're going to start to see, okay, we have two equations. How do we find our two missing variables? We're working with systems of equations in our next video. So please stay tuned. We're going to get to Pokemon, I promise. But first, we have to get through some more math. So I will see you all.